Now, we mentioned oxidation numbers a little bit ago, and we described how we can say whether something is an oxidizing or reducing agent, or oxidized or reduced, from its change in oxidation number. But how do we come up with these oxidation numbers? Well, we saw that with the sulfur dioxide, we considered that oxygen was actually going to gain all of the electrons in the bond between it and sulfur, and that sulfur was going to lose them. And so we determined that oxygen was going to be -2 oxidation number, and therefore sulfur would be +4. Now, you don't need to draw out the Lewis-Dot structures of all these things to consider oxidation numbers. In fact, there's some good old general rules which are much quicker to use. And so here they are. There are 6. First one. Let's say that you have O2. It's a free element. That is, it's not bound to anything else. Oxygen is by itself, and it doesn't have a charge here. So we're going to consider that its oxidation number is 0. What about if you have chlorine gas? 0. What about if you have sodium metal with no charge? 0. Okay, so if you've got an element by itself with no ionic charge, it has an oxidation number of 0. Second, ionic charges. If something does have an ionic charge, then that ionic charge is the same as the oxidation number. So let's say that you have sodium metal with no ionic charge. It's 0. But what if you have sodium ion, then it's Na+, right? And then its oxidation number is +1, because ionic charge is the same as oxidation number. Group 1A elements, like sodium or potassium or lithium, they have a oxidation number of +1 if they're charged, if they have a charge. Group 2A elements have a charge of +2. And only in group 3, the only one that's fairly consistent is aluminum. It's +3 if it's charged. Next, oxygen. If it's bound to something else, then it will often have a charge of, or oxidation number of, -2. However, if there's an oxygen bond, but not in O2, but say in hydrogen peroxide, any peroxides or peroxide ions, those oxidation numbers will be -1. What about hydrogen? If it's next to something else, say like in water, it's going to have an oxidation number of +1. And if it's next to something like a metal, actually, if it's next to a metal, it's going to be -1. So that's called a hydride, if it's hydrogen with a -1 charge and oxidation number. Fluorine, its oxidation number is going to be -1. That's its only oxidation number if it's next to something else or is charged. And finally, the most detailed one, the sum of all the atoms' oxidation numbers equals the overall charge of the compound. So consider that sulfur, in sulfur trioxide, sulfur has an oxidation number of +6. And oxygen has an oxidation number of -2. Now, we can create an equation for that rule. And the equation is the summation of the overall of the oxidation numbers, i.e., the summation of the number of atoms of each element times its oxidation number. It all adds up to the compound's overall charge. So add up the sulfurs +6 with 3 -2s, so +6 and -6. That gives an overall charge of 0. So that's just sulfur trioxide. But what if you had sulfur with an oxidation number of +8? Well, then you'd be combining a +8 with 3 -2s. You'd be combining a +8 with a -6, and the oxidation number would be, let's see, actually, what I meant was +4 here. What if it were +4 then you would have plus 4 and minus 6. You'd have an overall charge of minus 2. That's sulfite. What if I told you you have sulfate, SO4 2 minus, and I asked you what is the oxidation number of sulfur? Again, you want to use this equation to solve the problem. So the oxidation number of that one sulfur combined with the oxidation number of those 4 oxygens gives an overall charge of minus 2. So what is the value of x? X minus 8 is equal to minus 2. So x is equal to minus 2 plus 8. X is equal to plus 6. Okay, so here you can determine that oxygen has, actually sulfur has an oxidation number of plus 6. A couple other things. Metals always have positive oxidation numbers. So sodium can't be minus 1. It's either 0 or plus 1. Transition metals, so group D, D block elements, and also nonmetals. Most nonmetals can have several oxidation numbers. So you're used to thinking that, say, bromine is minus 1, right? Well, in fact, it can have several oxidation numbers, positive and negative. It can range between, I think, positive 7 and minus 7. It's really going to blow your mind. All right, so let's try some practice problems here. Let's see. What is the oxidizing agent? What is the reducing agent in this reaction? Okay, so in order to determine what's oxidized and reduced, therefore, you need to consider the oxidation state first. So what's the oxidation state of fluorine? This is F2. It's just a fluorine molecule. There's no charge. You don't see a charge. And so you know that it's 0 oxidation state. And what is the oxidation state of the fluorine here? Well, we see that it's stuck to a sodium. And so consider the charge of the sodium. There's 1 sodium, it's plus 1. And we're looking for the oxidation number of fluorine here, but we don't know it yet. The overall charge of this compound is 0. So the combination of all the oxidation states is equal to 0. So 1 plus x is equal to 0. X must be equal to minus 1. And so fluorine is minus 1. Fluorine is going from 0 to minus 1 oxidation number. Let's see. So it's going down the number line. You know that it is being reduced, which means therefore that F2, if it's being reduced, is your oxidizing agent. Now, what about within the sodium bromide? We know that sodium is always plus 1, right? So what's that oxidation number of bromine here? It must be minus 1. And then it's turning into the bromine element in elemental form, or bromine molecule. It's going into 0. Bromine is going from minus 1 into 0. So it's going up the number line. It's being oxidized. If bromine itself is being oxidized, that means that sodium bromide is your reducing agent. Next, this one's a little bit trickier. This next problem, which is actually quite similar to a lab we'll be doing this week, is the reaction of sodium thiosulfate with iodine to give sodium iodide and sodium, Na2S406. So again, to determine whether something is reduced or oxidized, you need to see how its oxidation number changes. So let's see. Let's look through this here. You know sodium is plus 1. It's either plus 1 or 0. Here it's stuck to something else, so it's not by itself. It's part of a compound. It must be plus 1. Oxygen, unless it's part of a peroxide, it's minus 2. So what's the charge of that, or what's that oxidation number of the sulfur here? Well, we know that the ionic charges of all these guys combine to give the ionic charge of the overall compound, which is 0. So 2 times plus 1 plus 2 times x plus 3 times minus 2 is all equal to 0. So 2 plus 2x minus 6 is equal to 0. So 2x is equal to 6 minus 2, or 4. So x is equal to plus 2. Okay, so that sulfur is plus 2 originally. And what is it changing into here? So do similar calculations here. You know, sodium is always plus 1 if it's next to something. And oxygen, unless it's part of a peroxide and it's stuck to something here, it must be minus 2. So what is the oxidation number of your sulfur here? It's X. Sulfur X, and weirdly, X is actually positive 2.5. Yes, you can have fractions as your oxidation number. And so sulfur is going from plus 2 into plus 2.5. It's going up the number line. It's being oxidized. Sulfur is being oxidized, which means that sodium thiosulfate is your reducing agent. Iodine is going from 0 to, let's see, plus 1, minus 1. Iodine is going from 0 to minus 1. It's being reduced. It is your oxidizing agent. All right, thanks for watching, guys.